Good morning, students. This is my lecture on acid-base balance, and I decided to do this lecture online is because you need to know the ABGs, and to understand ABGs, we need to understand acid-base balance. Now, acid-base is dependent on a pH of any solution. Um, there is a scale which runs from 0 to 14, and 7 is the midpoint of that scale, and uh, the human blood is from the human blood's pH, is from 7.35 to 7.45, and that's the normal pH for the human body. And if anything happens to this pH, the entire homeostasis of the body gets disturbed, and person can go to coma and even die. So we need to understand what is acid and base. There are some normal ABG's value which you need to memorize. There's no, you have to memorize these normal values uh, for ABGs. Like it's given in your book also. The pH, the normal pH, which is a hydrogen ion concentration, it is from 7.35 to 7.45. The normal PCO2, which is partial pressure of oxygen, it is 35 to 45 millimeters of mercury. And then the partial pressure of oxygen, which is PO2, is 80 to 100 millimeters of mercury. And then bicarb, which is HCO3, it is from 22 to 26 MEQ per liter. These are the four normal values which you need to memorize in order to understand ABGs, in order to understand how these values will uh, show any complications in patients on the floors. Now, before we get I explain you further, let's go to the next slide. Um, now, our, our our body pH should be always healthy. That's what we are aiming for. And if if it becomes acidic, then anybody can have a lot of diseases like cancer, heart conditions, arthritis, gout. All this can happen if the pH is getting deviated from its normal value. Uh, Now, what is a pH? pH, the full form of pH is particles of hydrogens, and uh, and it's important to maintain a stable hydrogen ion concentration in our body fluids. It's not just important, but it's very, very important that we maintain this hydrogen ion concentration in our body. pH can be, based on its value, it can be acidic, and based on its value, it can be basic. Now, when they talk about alkaline, basic and alkalines are the same thing. So, and the whole pH scale runs from 0 to 14. So, if you go lower than lower towards 7.35, then it's because you're going more towards, if you go more towards the zero of, then the solution is becoming more acidic. If you go more towards 14, then the solution is becoming more basic or alkaline. I'm not expecting you to memorize the pH of all the solutions but for our purpose for this nursing school and for the nursing career, you need to know the normal pH or the hydrogen ion concentration in your blood, and which is 7.35 to 7.45. Now, a normal human being, not somebody who has some kind of disease or disorder, a normal human being can maintain the pH of his blood by controlling what he eats. So, and there is a whole lot of lecture by many nutritionists who know, how what we consume in a body decides our body pH. And usually the high protein diet, coffee, stress, even sugar, they say sometimes a lot of sugar, not basic sugar, but a lot of sugar can lead to acidotic state in our body. Coca-Cola is supposed to have a pH of 2.6, so it is going more towards the zero. It's becoming highly acidic. It's a killer. And if I go to I have a table in the next slide. So if you look at this, all the sports drink, artificial sweeteners, blueberries, cranberries, chocolate, peanuts, beer, wine, they're all supposed to be called acidic foods. And if you go towards right, you see the honey, sugar. Now, sugar can be both alkaline and acidic. It depends on, processed sugar is more of acidic. Oranges, bananas, pineapple, almonds, olive oil, green tea, this is all alkaline. Now, are we supposed to just eat only alkaline foods? No. It's recommended by nutritionists that any uh, person to have a balance of acid-base balance in their body, they should have at least 80% food from the 80% of person's diet should be from alkaline and 20% from acidic forming foods. So that's what is usually recommended. Now, leaving this aside, let's go back uh, to our solution, or to our fluid we were talking about, was the blood pH. Now, blood pH and life. It's very important, as I said again and again. It's not just ABG, it's pH, and pH is, even if a patient comes to a hospital or facility and he has a disorder, and if we don't control his acid-base balance, it is more fatal than the disease itself. So it's very important for us to understand the uh, changes in the small changes which can happen on floor in the patient's acid-base balance. Um, if blood pH is 8, so suppose from 7.4, 7.45, it goes to 7.8 or 8 or something like that, the patient will go in coma and will die of alkalosis. So remember I told you the normal pH is from 7.35 to 7.45. So if suppose imagine the patient's blood pH is 8, patient will go in coma and will die of alkalosis. If blood pH um, goes down to 7.22, patient will then go in coma again and will die of acidosis. And now, in normal circumstances, our body is made naturally to maintain this acid and base balance. And the two organs which do this are lungs and kidneys. We just learned we have a gaseous exchange in our body during respiration. Uh, by taking more oxygen in our body, we are becoming adequately balanced basic state person. So if we take more oxygen, we are becoming basic. And if we are giving out carbon dioxide, then we are reducing acidic in our body. So we need to have a good balance in our body. So lessen the acid and increase the basic. And none of them should be too high or too low. So it should have to be a balance. And who does this? Lungs, naturally lungs, because lungs are doing the expiration and inspiration. So they are taking oxygen, making the body basic, and giving out carbon dioxide, making the body less acidic. So how kidneys will help? Now lungs will do this faster. Kidneys will do it a little slower. Now how kidneys help? Kidneys are constantly monitoring the pH of blood too. Kidney has filtering units. Uh, I don't know if you have done the renal lecture in detail, or maybe I'll be teaching you the renal lecture in detail. Kidney has a lot of filtering units, and those are in Bowman's capsule, and 1 million filtering units in each kidney. So there are a total of 2 million filtering units, and there are some structures called tubules. And in tubules are those structures where every day 1800, approximately 1800 of filtrate is passes. And what happens is those tubules, the kidney tubules, um, they keep whatever is essential for the body, and then the rest is going out of the urine. So if it is uh, in any given 24 hours period, approximately 1800 filtrate passes, 1600 is reabsorbed. So, and 1.5 liters eventually goes out of your urine, and the 500 ml has what is left, and that is what you have your electrolytes and important nutrients in that 500 ml. Now, in the reabsorption section of the kidneys, tubules, pH is balanced. So kidneys maintain pH of blood in its tubules. Now, if blood's pH is acidic, the blood will drop that extra acid in tubules, and eventually from tubules it will be taken to urinary system and it will go out. And if blood's pH is alkaline, then blood will keep some acid from that filtrate which was going around in the tubules, and it will make itself acidic. So if it doesn't want kidneys, if it doesn't want acid, it's too much acid, it will drop that extra acid in the filtrate, which is, or in the tubules, and then it will go through the urinary system and go out. But if the blood is alkaline and needs more acid, then while it is filtering, it will keep some acid to itself, so it can level the pH of blood. So that's how kidneys contribute in maintaining the pH of pH of blood. So that's how kidneys and lungs, they both are acting. They both are responsible for maintaining the pH of our body, and they do it naturally. We are not telling them to do it. They're doing that all the time naturally. So it's a good thing. So it's a good way where the kidneys and lung maintain the pH in our body. Now let's go to the next slide. Now, how acid is acid and how base is base. What makes an acid, and what makes a base, a base. So if there is a solution, any solution we are talking about here, what will make that solution, the solution which we are talking about here, what single thing will make that solution acid? What makes an acid an acid? So the hydrogen ion, the H plus, the hydrogen ion concentration, that's make any solution acid. What makes a base a base? If that H plus hydrogen ion, that H plus hydrogen becomes a bicarbonate ion, then a bicarbonate will make a base a base. So if many hydrogen ions are present in a liquid, this liquid will be an acid, and the pH will decrease. The more acidic the solution is, the lower the pH. So there is a liquid, and we add more hydrogen ions to it. And if we add more hydrogen ions to it, it will become acidic. When it becomes acidic, the pH of that solution will go down. Remember that scale, 0 to 14, 7 is the midpoint, we're going down. So pH is becoming going down and down. So pH is going down because by adding by the hydrogen ion, then the pH, then it says that the more acidic a solution is, lower the pH will be. So just remember that more acidic the solution is, lower the pH. Uh, Now, if we take this solution uh, and we put the solution in the patient, what will the patient become? So if this liquid is infused into a patient, that will make the patient acidotic because hydrogen ions are acidotic. So hydrogen ions makes any solution acidotic, and when hydrogen ions is added to a solution, it becomes acidic, and as soon as it becomes acidic, the pH goes down. And if you and then whatever the solution is made, if you put this solution inside the patient becomes acidotic because hydrogen ions are acidic. Now just think of the opposite. If we put in the solution a base like bicarbonate, so what will happen? The pH will increase. So more alkaline the solution, the higher the pH. And if this basic solution, which has uh, uh, higher pH, if it is infused into a patient, the patient will become alkalotic. So see, now you see how it's going. When pH goes up, when pH goes up, the, the solution becomes more alkaline. When the pH goes down, the solution becomes more acidic. So this is the key thing which you need to remember all the time. Uh, Now, if you remember the most important gas in our body, we have oxygen in our body. That's the most important gas. But the major lung chemical which controls which is also a very important part of our homeostasis is carbon dioxide, and carbon dioxide is an acid. So the major kidney chemicals are bicarbonate and ion hydrogen ions. So carbon dioxide is the major lung chemical which is found in lungs. The bicarbonate and hydrogen ions are the kidney chemicals, and they are found in kidneys. I'm just telling you to note this for now, and I'll tell you how you'll understand this, that why I need to know that carbon dioxide is a main chemical of lungs, and then how the bicarbonate and hydrogen ions are of kidneys. Uh, so carbon dioxide is always an acid, and it's an acid because the minute the carbon dioxide comes into our body and it mixes with water, it turns into a carbonic acid. So carbon dioxide is an acid. And when there is a lot of carbon dioxide in our body, the patient can become, when there is a lot of carbon dioxide in our body or in a patient, the patient can become acidotic because carbon dioxide is an acid. Now, if we are not exhaling the carbon dioxide, and if the carbon dioxide is retained in the body, which organs won't work correctly, or which organs uh, are not working correctly? Remember, I said carbon dioxide is related to lungs, and then bicarb and hydrogen to uh, kidneys. So, if there is a lot of carbon dioxide in the body, then which organs is not working? Definitely it's lungs, because carbon dioxide can only be excreted by the lungs. So if carbon dioxide is building up in the body, then the lungs are not doing their job of excreting the carbon dioxide. Now, if a patient is in respiratory acidosis or alkalosis, so the problem is with the lungs or with the kidneys. It's with the lungs. So whenever we're talking about respiratory acidosis, alkalosis, now remove the acidosis, alkalosis from your mind, or just think about respiratory. When we're saying respiratory acidosis, alkalosis, we are thinking about lungs, lungs, lungs. So the think respiratory is equal to lungs. Now, in the patient who has disease and if their lungs are sick, they have a disorder, then what organs will try to compensate for the job of the lungs? The organs which will try to compensate for the job of the lungs will be the kidneys. If the lungs cannot get rid of the excess carbon dioxide, then the kidneys are going to go to work to try to correct that problem. The kidneys would like to control the pH back to normal range, and the kidneys has two chemicals which are bicarbonate and hydrogen, and they will use those chemicals to correct the pH. Now, in this example which I was giving, when there is too much carbon dioxide, the kidneys will kick in and they will secrete bicarb into the blood, and they will excrete hydrogen out of the body. So when lungs are not working, the there is too much carbon dioxide, the patient is not exhaling carbon dioxide, the kidneys will kick in and it will try to secrete the bicarb into the blood and excrete hydrogen out of the body. Now, if the lungs are getting rid of too much carbon dioxide, as with hyperventilation, then the patient will become alkalotic. So in the earlier I said the body is keeping the carbon dioxide. If the body is keeping the carbon dioxide, the lungs are not working, then the kidney will come and play its role, and it will use bicarb and hydrogen, and in an effort to correct the pH. When the kidneys will secrete bicarb into the blood and they will excrete hydrogen out of the body. Look in the other way. Now, if look from the other point of view, if the lungs are getting rid of too much carbon dioxide, they are not retaining, they are getting rid of too much carbon dioxide. We need carbon dioxide um, to a certain extent in our bodies to maintain homeostasis. And if the lungs are getting rid of too much carbon dioxide, as with hyperventilation, then the patient is becoming alkalotic. Now the pH is out of range, so the kidneys will again come and they will do their part. They will try to again compensate, and they will again use those two chemicals, bicarb and hydrogen. Since the kidneys are trying to correct the alkalosis now, they will excrete bicarb from the body and retain hydrogen. So when there is too much carbon dioxide in the body, the kidneys secrete bicarb in blood and excrete hydrogen. Okay, and if in the body there is not much if in the body when there is not much carbon dioxide, if in the body there is not much carbon dioxide, then kidneys will try to correct by excreting bicarb away from the body. So instead of putting the bicarb into the blood, as with acidotic state earlier, uh, uh, they will now try to excrete the bicarb from the body and retain the hydrogen. Now, if the patient is in metabolic acidosis or alkalosis, then the problem will be always with kidneys. So lungs equal respiratory, metabolic equals kidney. So, and as I said earlier, the kidneys compensate very slowly, but then they are much more efficient in the lungs. They're much more efficient than the lungs. Kidneys The whole process of kidneys correcting the pH of the blood or the pH of the body, it will take anywhere from 1 day to 4 5 days when they start doing the compensation. So kidneys do it much slower than lungs. Now, if the kidneys are sick, which organs do you think will compensate for the malfunctioning kidneys? Automatically, it's lungs who will compensate for that. So lungs are going to compensate by either blowing off the excess carbon dioxide by increasing respiration. So they will increase the rate of respiration. So the body is getting rid of the excess carbon dioxide. Or they will retain the carbon dioxide by slowing the respiration. How the respiration will change will depend on whether the client is experiencing metabolic acidosis or alkalosis. So, so lungs compensate quickly and kidneys compensate slowly. Uh, so now kidneys don't blow off carbon dioxide. Just remember that lungs blow off carbon dioxide. Okay. Now let's review what we did right now. We said that hydrogen is an acid, bicarb is a base, and the more the acidic the blood is, the lower will be the pH, and the more basic the blood is, the higher will be the pH. So, and then we discussed how kidneys and lungs, they compensate for each other when the body's pH is imbalanced. Uh, let's look at the respiratory acidosis and alkalosis. Uh, we talked about it. Before I say anything, just remember the brain likes the body pH to be perfect all the time. When the pH gets out of normal, then the patient's level of consciousness will change. So, with any acid base imbalance, think about the LOC patient's LOC. That's very important, and that's one of the signs and symptoms too. So, the lungs have one chemical, carbon dioxide. Now, let's talk with the. Let's first understand respiratory acidosis and alkalosis in a little detailed way. So the lungs have one chemical, carbon dioxide. In an acid-base balance, when we say there is a respiratory acidosis or alkalosis, that means there is something wrong with lungs. Lungs are sick. That's why we are using the term respiratory. Anytime the lungs are sick and they are causing respiratory acidosis or alkalosis, the problem is due to the carbon dioxide. So respiratory equals carbon dioxide. So problem with carbon dioxide. Now to correct a respiratory imbalance, the compensating organ is kidney, because at that time when the lungs are sick, they cannot compensate for themselves. And when the lungs are sick, the kidneys compensate by manipulating the chemicals bicarb and hydrogen to correct the imbalance and bring the pH back into normal range again. And this is done by secreting bicarb and excreting hydrogen. The kidneys are slow, but they are affecting and compensating for respiratory acidosis or respiratory alkalosis. Now uh, let's talk about the what do we say metabolic uh, metabolic acidosis and alkalosis. The problem organs in metabolic acidosis and metabolic alkalosis, now we know, has to be kidneys. Bicarb and hydrogen are considered the problem chemicals when the kidneys are sick. So since the kidneys are sick, they are not able to maintain the homeostasis, that is, to maintain the normal pH. So a different organ will help. So in metabolic acidosis or metabolic alkalosis, the compensating organs are the lungs. Okay, so just remember this. They kidneys and lungs, they compensate for each other when one of them is not working properly to maintain the pH of the blood. So this is the little overview I wanted to give you about the acid base imbalance and how the pH plays its role and how the kidneys and lungs compensate each other. So there is a for ABG analysis uh, there is some formula which you need to uh, which I said there is some kind of mnemonic which you need to memorize. Let's go to next slide. It says Rome, so respiratory opposite, metabolic equal. So it says when the pH is high and PCO2 is low, then it has to be alkalosis. And when then pH is low and the PCO2 is high, then it has to be acidosis. But if the pH and partial pressure of carbon dioxide relationship is opposite, then it is respiratory problem. Now, and if the pH is high and bicarb is also high, and the pH is low and bicarb is also low, that means it's going side by side with pH and bicarb are going side by side. They're not opposite, they are equal. Then it is a metabolic problem. Okay, so you need to memorize this mnemonic too. Let's do a question here. So suppose pH is 7.55, PaCO2 is 20, and bicarb is 19. So pH is 7.55. So the normal pH range is 7.35 to 7.45. So its pH is going high. So the pH is going high, it is alkalosis. Then PaCO2 is 20. So if PaCO2 is 20, that means the carbon dioxide is out of normal. It's low because the normal is from 35 to 45. And then bicarb is supposed to be 22 to 26. So, and it's low. Bicarb is low. So this is based on these values. This is respiratory alkalosis. When I see in you all in class, I'll give you some more calculations, and then you will be able to know how you can understand if it's a metabolic or respiratory problem and how alkalosis or acidosis. Look at one more example. pH is 7.35, PaCO2 is 42, and HCO3 is 25. There is nothing happening here because all these numbers are normal. So there's no acidosis or alkalosis happening. I hope this is my first lecture. You're able to understand it. And if anytime you're not able to understand me, please meet me in class or see me in my office. Okay. Thank you.